Okay, so they could get a little more complicated, but they still follow that same end behavior. So because the leading one, okay, the index of this entire thing, no, degree. The degree of this entire thing is 3. That's odd, so it should start somewhere and end going the opposite of that. Okay? It should start somewhere and end going the opposite. It's positive, so it should start at the bottom and end going towards the top. Yeah?
You still need both infinite, right?
Yes. Yep. Okay? This is odd, so it should start somewhere and end going the opposite. But it's negative, so it's going down the graph eventually. Okay? Odd, so it starts down, but ends going up because that's positive, but it is odd, so their end directions are different. Down here, it's even. So 4, so that means we start somewhere and we end going that same place. Okay, so that's similar to the quadratic. It's similar to a U. It just has a couple things in the middle that do something weird. Okay, here it's negative, but it's even. So it starts at the bottom, does some stuff, but then goes back to the bottom. So the end behavior matches on evens. Okay? There's also a couple other things in here. These are the zeros. So this is what we've been solving for. So if you did, synthetic division and stuff on this, you'd end up getting this. And then you can figure out your zeros, and that's where we can put those 3 spots. 1, -2, and -3. 1, -2, -3. So you can put those 3 spots and then just test something between them. Again, easiest way is to store it on your calculator. Store it as x. It'll make these problems go a lot faster. Okay, how about this one over here? If you look at this 0, what did we call that 0? If it had a 2. What was the word that we used that you had to do it twice? Multiplicity. So if you see that 0, you actually bounce off the x-axis. So with multiplicity, you don't actually go through it. You go down to it and come back up. So that's multiplicity. So you can see multiplicity here at -1. So that's why there's a squared at x plus 1, because the 0 would be -1. So that's a sign of multiplicity on there. Okay, so examining translations. So first we know that this is an odd, right? So it's going to start, it's odd and it's positive. So it's going to start down here somewhere, and it's going to end going up here somewhere. We don't know exactly right now, but we know because it's odd, it does that. Okay? And because it's positive, it does that. We know that our middle of our graph goes down 2 because that's a vertical shift. So from the origin, it goes down 2. So our original spot is going to be right here. Okay? And then we want to test 2 points on either side of that spot. Okay? 2 points on either side of that x value. So on this one, I tested -2, -1, 0, 1, and 2. Do y'all have these tables made already or no? Okay. Okay, I chose those because they were on both sides of 0 because we're on x equals 0 here. So if I plug in a -2, -2 raised to the 5th minus 2. What? Those aren't actual endpoints. I was just saying I know that it's going to end going up and start being down because it's an odd exponent. Those are not actual endpoints. That's just showing my end behavior should be something like that. Okay, so if we plug those in, because it's to the 5th, it's going to take a little bit longer to plug those in, so I'm going to give you those answers. -34, -3, -2, -1, and 30. Okay, again, we want to test at least 2, maybe even 3 on either side of our center of our graph. Okay, so if I put those other 2 dots on, or the other 4 dots on there, then I get negative 2, 34. That's not on our graph. So then we can go to negative 1, negative 3. And then 1, negative 1. And 2, 30. So that's going to be way up here. And this is going to be way down here. So our graph should look somewhat like this.
Will you ever not start around 0, like the negative 2, negative 1, 0, 1, 2?
Yes. So the next one we're starting at negative 1. That's because we were shifted to the left 1. So it all depends on the x-axis. So this one we were shifted down, so we still started at 0. But if we're shifted left and right, we want to do an x value on either side of it. Okay, so that's what your graph should look like, and that's pretty much what we guessed around because we knew it started down here and ended up here. Okay, so this one is a horizontal shift. Inside is opposite, so that's going to move to the left 1. It's going to go towards the negative 1. So our original point is here. And then we're testing points around that negative 1. So I chose negative 2 and 0, negative 3 and 1. Okay, so I'm going to plug those in. Again, I'll tell you those answers. That's 64, 1, 0, 1, and 64. That's good because we know that this is an even function, so it should be a U shape of some form. Okay, it should look somewhat like a U shape. So we can't put negative 3 and 64 on, but we can put negative 2, 1. And we can put 0 and 1. So here's our second point. Okay, that's what our graph should look like. And all of it depends on our original shift and then things on either side of that original shift. Okay. All right. So even though we're going to be dealing with problems a lot bigger than this, it's still going to be that similar process. This one's a little bit bigger, but it's still the same thing. We got something outside. That outside thing is going to move us up 3, and our inside thing is going to move us to the right 1. So right 1 and up 3. So this is our original point right here. Okay, we know it's got an odd exponent, so its in behavior is going to be opposites of each other, but it's got a negative out front. So that negative out front is going to make it go down the graph. So our in behaviors are going to be more like this. That's obviously not the graph line, but it's going to be up here and down here because it's going to be going down, but it is odd, so it's opposites. Okay, our x value is 1, so that went in the center of my table. And then we're going to put dots on either side of that. So if I plug that in, it's 19, 5, 3, 1, and negative 13. Let me erase those in behaviors. So at negative 1, 19, we can't put that on our graph, but at 0, we're at 5. So that's up here, 0, 5. And then 2, 1, over 2, up 1. There's our second point. And 3, 13, we can't graph that. So it should look something like this. Just like always in my class, it does not have to be perfect as long as your points are. So this is very similar to what we've done for a few years, actually. So today we're going to add on a little bit more, and that is turning points and end behavior. Okay, so a polynomial function of a degree n, so n meaning the highest exponent, has at most n minus 1 turning points. So if it's to the degree of 4, there are 3 turning points, with at least 1 turning point between each pair of successive zeros. All that means is when you find your zeros, there's going to be a turning point between those. If there's 2 zeros here, it's going to turn and come back. Okay? Because it can't go back to the x-axis without turning around. Yeah?
What's n?
N is the degree, so like on this one, n would be 6.
Okay.
So
So 5.
5 turning points at most. Didn't have to, because ours only have 1 turning point. But at most it could have 5.
So if you continue to go, could it turn more? Like if you, because it goes on infinite, could it turn more?
No, at most it's allowed to have 5. That's why the end behavior is important, because once it goes up, it's not going to have another turning point, because it's never coming back down. Turning point is when it changes direction completely. End behavior is determined whether or not n, so the degree is odd or even, which is what I've been talking about. Okay? So here, I just want you to tell me what the end behavior is. So first, we need to look at our first part, this. So that is an odd and a negative. Okay, odd means that the end behaviors are going to be opposite of each other. And negative means it needs to end up going down in the end. So they're going to be opposite, and it needs to go down. So it'll look like this. Okay, but you can put an arrow on this other side too. Okay, and a lot of people, again, get confused because this looks like it's going up. You always read the graph from left to right. So from left to right, that is going down. Okay, so it's going down because it's negative, and the end points are opposite because it's odd. Okay, same thing on this one. Exact same thing, actually. Odd exponent, so they're going to be opposites. And it's negative, so it's going to go down. So exact same line. And I think on my math lab, they actually have them separate. So it'll look more like this. It doesn't have them connected. Okay, last one. The exponent is even. So even means it's going to be like a U shape, like a quadratic. So both are going the same direction. So even is the same direction. And it is positive, which means we're not going to flip it over any. So it just looks like this. Or it could be split like this. Okay, I believe those are multiple choice problems on the homework. Just asking which direction it ends up going. Okay, negative is down, positive is up, just like it's always been.
So will those be like, will it be like, like kind of like an ABC type thing?
Mm-hmm. Yep. Can I move on from that, Carson?
Yeah.
Oh, you were writing down the problems too, so I'll give you a little bit. Okay, so this next one is the harder problem. So let's keep going. Okay, next page. So graphing a polynomial. So we need to graph this. In order to graph it, we need to find zeros. Okay? I showed you last class. There is a way to find it on your calculator. But again, you can, on every problem they're going to give you on my math lab right now, you can divide it by 1. Okay?
Divided by 1.
What?
What do you mean divided by 1?
Like synthetic division? A 1 as your k. As 1 is going to be your 0 most of the time. So I would test that out. The way we would actually do this, if you don't have a calculator, would be the P over Q that we talked about at the end of last class. But I'm going to put a 1 as K, and then 1, 4, 1, and negative 6. Bring this down. 1 times 1 is 1. 5 times 1 is 5. 6 times 1 is 6. 0. So that does show me that 1 is a 0. So that is x squared plus 5x plus 6. So down here, f of x equals x minus 1, because that's our first 0 we just figured out. And then we need to asterisk this next part. X squared plus 5x plus 6. So in between here, I'm going to just do a small asterisk. 6, 5, 1, and 1. That's 5 times 1. So f of x equals... Yeah. X minus 1, and then x plus 5, x plus 1. Okay, I rushed through that, but that's exactly what we've done for 2 days. So we should be pretty good at finding those zeros, and then we can figure out our x's. Our x's are 1, negative 5, and negative 1.
Isn't your asterisk wrong?
Is it?
Yeah, you did 5 times 1.
Oh, it should be a 6.
Should be 3 and 2.
5 times 1. Oh, yeah. I was multiplying to get to the bottom. Yep, you're right. I was going way too fast. You were right. So that should be 3 times 2 gives you 6, and adds to get 5. Yeah, I just flipped it. Okay, plus 3 and plus 2. Good catch, Carson. I would have just kept on rolling. Okay, so there's your x's. I have the answer right here on my phone, and I just wasn't looking.
Bless you.
Okay, so those are your x's, so we can put those dots onto our graph. We know that those are our zeros and our x's, so we can put those down. So my points are going to be negative 3, negative 2, and a positive 1. Okay, and those all come from this right here. Okay, the other thing that's helpful is finding your y-intercept. You can find your y-intercept pretty easily because you just plug in a 0 for your x. So up here I'm going to find my y-intercept. Y-intercept is 0 in for x, so that's 0, 0, 0. So y-intercept is negative 6. So 0, negative 6. So we can also put that in right here. Okay, so we have all those points. Now if we know our end behavior, then we can know at least how this is going to look. The only thing that messes it up is that thing called multiplicity, so we need to pay attention to that too. Okay, last thing is we go through every one of those points. If it's multiplicity, we bounce through it, or bounce off it. If it's not multiplicity, we go through it. Okay? So we know that this is odd. So it's going to start somewhere and end going a different place. And it's positive. That means it starts on the bottom. So we're going to start down here somewhere. And we're going to go up through this first point. Turn, go back down through this second point and go back up and end going the opposite direction. Okay, that's how it should look. If we wanted to be really precise about it, what you would do, just like we did earlier this year, is test a point on every interval. So we would plug a -4 in using that store function and see where -4 would end up. It would probably give us a point here. And so our graph would be a little bit off right now. Okay, we would plug in something between these two, so it would be a decimal to plug in. We already plugged in a point between these, and then we plug in something on the end here. Okay, so that's how we get it to be more precise, but that should be at least a little bit how your graph should look. If you type it in on your graphing function, then you'll see that it looks somewhat like that. Yes?
When's our next off-campus lunch?
I have no idea. Yeah. What? Yeah.
Do you want to email again?
How was it Thursday? You don't
Two multiplicities on this.
Wait, so where did the multiplicity fit in on the last problem?
There was no multiplicity on that one.
Oh, okay.
Because nothing was squared in this.
Do we have to do the test thingy?
No. If you want to make sure you're correct, that's a way to check it, just like I've been trying to tell you to check the other stuff. But you'll figure it out. Okay, so this is multiple choice. Here are the graphs that you're trying to match it up with. So we have to decipher what our zeros are from this. So what are our zeros on this?
-3 and 2.
And what about this x? 0. So your x's are 0, 2, and -3. But we have multiplicity at two of them. So multiplicity at 0 and -3. And again, we had multiplicity because they were being squared. That means that it should bounce off of these 2 points. It should not go through those 2 points. Okay, so we should be on those points on the x-axis, but we should bounce off of them. So we need to look down here and figure out which ones go through those points. Okay, I know these graphs are small, but we can at least figure out a couple things. So this obviously goes through 0, and it bounces off 0, so that's good, because we know that we should bounce off 0 according to this. Okay, this one bounces off 0, so that's good. Bounces off 0, bounce it off 0, so that didn't help us much. The next thing, we need to figure out which ones bounce off -3. So that one looks like it goes through -3. Even though we're not positive that's -3, it's pretty sure that is. Okay? So this one goes through -3, so that can't be the answer. This one goes through -3, so that can't be the answer either. This one bounces off -3, and this one bounces off -3. So it's got to be C or D. The last thing we have to figure out is end behavior. So is our end behavior going up or going down? Okay, so the hard part about this is not, this is fully factored. So you can't just pay attention to the exponents, because if you look, that's squared, but the end behavior is going opposite directions. So if you ended up foiling this, it would end up being an odd degree. Okay? So you have to just be careful about that. So instead of just guessing, we need to check a point. So if I plug in on this interval, -∞ through 0, okay, on that interval, I'm going to plug in a -4. Actually, that should say through -3. Because we're testing everything until this point. And everything until this point. We're seeing if it's a positive or if it's a negative. So if I plug that -4 in and I store that in my calculator for all this stuff, I'll end up getting a -96. Because that is a negative, we know that our starting point, this needs to be down here somewhere, so we know D has to be our correct answer. Okay, so on this one, you cannot just look at that first point, because that does not tell you if it's positive or negative, odd or even, because it hadn't been FOILed altogether.
So you plugged in -4 for X on all of those.
Yep. Yep. Again, you can just store that and type this in, and it'll figure it out.
You drew the graphs really well.
Oh, those? Yeah. Okay, so I've been alluding to this the whole time. Intermediate value theorem. Okay, if f of x is a polynomial function with only real coefficients. So we had another theorem that was only real coefficients last class, and that was what? Anybody remember which one had to be real coefficients? Yeah? Conjugate, yes. Okay, the conjugate theorem. They have to have real in the problem and imaginary k. Okay, but if this is real coefficients and the real numbers a and b, the values of f of a and f of b are opposite in sign. So if you plug these things in, and this one gets a negative and this one gets a positive, then there has to be a 0 between those. And again, that's obvious because if the y value is positive and then the next one's negative, it had to go through the x-axis. So that's all that's saying. It's actually very straightforward, is if there's an x-axis between it, like this, if I plug in something and it's here, and then I plug in the next one and it's here, the only way to get from this to this is cross through the x-axis. That's all that means. Okay? So that's all that means. Intermediate value theorem just says if you plug in two things and they're opposite answers, we have to have a 0 between them. Okay? So if I plugged in A and B here, if I plug those in on my calculator,
Right, how are you doing this?
plugging it in? Good. Let's go over it again because a lot of people are
It's fine.
forgetting it.
Are you plugging this in the graph?
I agree.
What?
Are you plugging this in the graph?
Nope, I'm storing it. Okay, so we're going to plug those in. Let's see if I can do this. Okay, so you're going to store the -5, right? -5 is A. So I'm going to type -5.
Where did store come from? Where's store?
Store is right here.
Above on.
Above on, STO. Okay, store as X. Okay, and X is right next to alpha. If you don't know that already. So I stored it as X. Now I'm going to type that exact problem. So X, you might not be able to see it right now, but I'll line it back up. So X raised to the third plus 3X squared minus 9X minus 13. Okay, so I type that in, then you can just click enter. That gives us our answer. So it knows what X is. So if I type in, if I plugged in a -5, so F of -5, my answer is -18. So if I plug in the next one and the answer is positive, that means I had to go to the x-axis, so there's a 0 between those. So let's plug in the next one. And the best part about the store function, rather than plugging in using parentheses like you've been doing, is because you don't have to retype anything. So I'm going to plug in a -4 now. So -4 stored as X. And then I can scroll up and copy that.
Makes my calculator different because I put X and then store.
No, you have to do the number and then store it.
Yeah, you have to type the number first
5 store
How did you,
X.
where did you get negative
in the problem.
Oh.
Yeah.
Okay.
Okay, so when I plugged in that -4, I got a 7. So that's a positive answer. So if I got a negative answer and then a positive answer, that means that there has to be a 0 between those. So if I type in I can show you the store function after, but that's how you can check every one of those problems last section. Okay? I know I've showed y'all that.
So you use the two numbers they give you?
Yes. Okay, so if I type those in, those are opposite of each other. They're opposite signs. So that means, yes, there has to be a 0 between those. So your answer is yes there. Just yes, because it's asking if there's a 0 between them.
So like if it's positive, positive, so it would just be no? Like it was
Yes,
like 7
if they're the same sign, yes.
Why do we have to check if you say there's always been a 0 though?
What?
What is the yes or no for?
The yes is saying if there's going to be a 0 between those. So when you were graphing, if I plugged in a point here, if I plugged in 6, or if I plugged in 4 and got this, and then I plugged in 0 and got this, that tells us that there has to be a 0 somewhere between those, because it goes through that x-axis. So all you're using this theorem to figure out is if you cross through the x-axis between these 2 points.
Why can't we just say yes in the beginning? Because you said it was already passing through.
Because it might not have passed through between those 2 numbers. It's talking about these numbers. Yes, this passes the x. It's talking about between those 2 numbers. Okay, so same thing on the next one. If we store 2.4 as x and then type this in, we get a positive or a negative, and then store 4.2 as x and get a positive or a negative, we will know if there is a 0 between those. The first one's negative. The first one is negative, and I believe the next one is going to be a positive 154. So there is also, yes, there's a 0 between those. Yes, there is a 0. That's what that theorem says. Which, I don't know why it's called a theorem, because it's a fact. It's obvious. Okay? Almost. We are almost done. We got a backwards problem to look at real quick. You know, we always end with one of those.
A what?
We don't have to.
Yeah, we can do it now, you know.
Please tell me when
You're
I'm
gonna use the answers in the morning or after high school? Please.
You're not. You might not. You might not. Never mind. I think I said that wrong. Boundedness theorem. Okay? So again, it says all this stuff. We can go back to this and explain it better once I've actually talked about what we're talking about, and it might make more sense. Because whenever I read this the first time through, it just seems like gibberish. Let f of x be a polynomial function with the degree n is greater than or equal to -1. So the degree has to be greater than or equal to negative or positive 1 with real coefficients and the positive leading coefficient. So it's got to be positive. Suppose f of x is divided synthetically by c. Okay? It says if that should be k. I don't know why they changed it. But that's the same thing as k. So if k is greater than 0, all the numbers in the bottom row of the synthetic division are non-negative, then there is no 0 greater than c. Okay? It'll make more sense once we get it written down. Okay? If c is less than 0, the numbers on the bottom row of the synthetic division alternate in sign. Then there's no 0 less than c. Okay, so let's first show how easy this actually is. Okay? So it says, does this have any zeros greater than 2? Okay, we want to know if there's any zeros greater than 2. So first 2 is our k, so we're going to synthetically divide by 2. 1, 6, 4, nope, 1, 6, 0, 4, and 3. So regular synthetic division, so 1, 2, 8, 16, 16, 32, 36, 72, 75. Okay, so after you synthetically divide, all we have to do is look at these numbers. Okay, we look at these numbers and we answer this question. It says, if all the numbers in the bottom row are non-negative, Okay, are all those numbers non-negatives? Okay, if they are all non-negatives, I don't know why they said non-negatives instead of positive. Maybe because it's allowed to be a 0. That might be why. Okay, if they're all non-negatives, then there is no 0 that's greater than 2. So there are no zeros greater than 2. Okay, so if they're all positive, then there's no zeros greater than whatever you divide it by.
Whoa, the next one's less than.
Okay, so then they're on the next one, -2. So 1, 1, -1, 0, and 1. Bring those down. That is 1, -2, -1, 2, 1, -2, -2, 4, and 5. Okay, so we need to look if they're positive. Are they all positive? So we can look at our next thing, and it says if the bottom row is alternating signs. So the bottom row has a positive, a negative, a positive, a negative, a positive. So if it's alternating signs, then no 0 is less than C. So no zeros less
Are we going to have to remember this theorem?
than -2. You'll see on the homework, it's a lot easier than what it's making it right now, because they're multiple choice type problems, if I remember correctly. All you're going to do is synthetically divide and see if they're all positive, there's nothing bigger than this number. If they're alternating, then there's nothing smaller than this number.
So it's like the sign, so like if it's
Positive, that's going to be bigger.
greater and then less than is.
Yeah. Except that one's
That makes sense
alternating.
in my head.
Yeah, yeah. I know exactly how you're thinking it. You're saying it. Okay, last thing real quick. Let's just take a look at it. Okay? The last thing is one of those backwards type problems. Okay, so we know that it says find the polynomial of least possible degree of the graph shown. So f of x equals a, parentheses. We know our x's, so x plus 6, x minus 3, x minus 4. So same thing as before. We know our only other points. So if we plug in a 0, it should get us 36. So 36. A, if I plug in a 0, that's 6 times -3 times -4. So I solve that out. That's 36, 72a. Divide both sides by a 72. And I get a equals 1/2.
Why did you pick 36? Because of the 0?
Because this is the only point we know. So that's the same thing on the last homework where they said f of x equals this, but they didn't do f of 0 equals 36. They just did 0, 36. Same thing. Okay? And then we just have to put a back at the beginning. So f of x 1/2 x plus 6 x minus 3 and x minus 4. It does say to the least possible degree, so I think that's the reason I left it this way. I don't think you actually have to FOIL that one, but just make sure on the homework. If it doesn't count that right, maybe FOIL it out and make sure. But you can see that's the exact same problem you did on last night's homework. You just didn't have to FOIL. That was the hard part on last night's homework. All right.